Hello everybody, welcome to another video. And before I show you my improved script, I just want to show you when you want to use this script from the previous video on the real project, what you will have as a result. I did mention immediately when I created that previous video that this script has some problems when using to real life projects, but we must start from somewhere, so I will again show this previous script on this project. This is the Autodesk sample project, and then I will show you new script. So run, refine, you will have something like that. It's not very useful, and I did make huge mistake over here. So if you want to play with this script, if you already invest some time to create this previous script, you want to play a little bit more with that script. So right up here, when I from one side deliver the points, from the other side I needed to deliver elements, in this case ducts. So I did create this filter for the points, but I didn't create the same filter on the ducts. So when you create this filter over here, it will improve a little bit those results. So you can see it is a little better, but again it's not perfect, of course, and I did create basically entirely script. I did adopt some of the earlier solution that we have in this script, but I think 80% of this new script is entirely new. And also I did resolve this problem. So when you want to crop some part of the view and to tag that view in this script, you did also tag some things which does not belong to this view, and I did also resolve that in this new script. So now I will delete all those tags. I will run new script. So this is the new script. We will go into details later. For now, let's just say that I'll filter all ducts which have a length less than a half a meter. The offset is the same, it's 2000. The category is duct. And now we will run the script. And now in one run, the script will create initial tags and refine. I don't need to click twice. So now you can also run this script from the Dynamo player. Now you will just click one and basically the script will run twice because it has those start and end nodes. But I think it is necessary, and I think it is better for users to run the script only once. So let's now see those results. Again, it's not perfect. It is now entirely new approach how I group those points, but we have problems with this tag over here, with this tag over here. I will explain why. Also, this couple of tags over here are the problem, but these tags over here okay, these tags over here okay, and also those tags over here are okay. And now one thing which is not related to the script, it is related to the tags itself. So I did put like over here the point where the elbow should be, and it needs to be straight line. But when you have this situation that you don't have straight lines between the elbow and the head of the tag, it is in the 99% of the cases problem with the tag. So this is the Autodesk project, Autodesk generic tags. But now when I go to family and I turn on annotation categories, also turn on border, you can see that this tag is not on the center of this reference plane. So you need to make this tag on the center. So now when I load this tag back to the project, I will just turn off this border. Those lines should be straight. Okay, and yeah, now this line between the elbow and the tag head, it's straight line. So if you have problems with this part over here, you will need to edit your tag. And now let's see how I did modify this script in the term of the algorithm. So when we take a look at the script, this part over here remained the same, but basically this entire part over here it's new. And now this area, so this area over here, it's basically defined by the crop. So even if you have some view in which you don't have a crop, you will need to turn on crop and crop region visible. You will need just to define crop around your view in order for script to get to know the boundaries, because in the previous script I did use determination of this area by the elements of category. So you can have situation that for all elements inside some area everything be okay, but you will have the duct with a large length over here, so it will create some strange area in which you will have elements here, you will have one element and nothing here, and that makes hard for Dynamo to recognize how to group those points. So now we will define the crop, we will define this outer offset for tag head, this inner offset for tag elbows, and that is why you should have always straight lines over here. And moreover, now if you have some area like this, the first thing which we need to find is middle point. So let's say that here we will have middle point. And also the same logic regarding the quadrants is the same, and we will need middle point for this quadrant number 1 and for example quadrant number 3. So now we have overall the middle point of this entire area. We have middle point of this quadrant number 1 and middle point for quadrant number 3. And now my logic was following. So in case that we have some points, I don't know, over here, some points over here, some points over here, and some points over here. So how we will determine and group those points? And also we have area, we have middle points, we have coordinate system, and let's say that those green dots and lines are the actual elements, actual points. And now we need to figure out how to group them and how to assign them to those points regarding the tag location. So I did have a couple of ideas. Still, I think that you can improve this script, but you need to invest a lot of time. So I will again stop here. So now my idea was I will check all points, and if the points have this x component smaller than a component which is in this point, I will declare those points to belong to this group over here, which is called left. So everything here will be called left. It is basically the same for this area over here. So again, I will check if all those points over here have this x component larger than this point over here. If they have, I will assign them to be in the group right. Now I will not check further, and I will not play with these points for which I already know that those points are belong to this group left and group right. So now I want to check if all those points over here have this y component larger than in this point which we have in the middle for entire area. If the value of these points over here regarding this y component is larger than this point over here, I will assign them to be in the group up, and at the end I will not check anything for this group over here. I will simply say, okay, took all the points that we have and then exclude points which belong to the left, right, up, and all the points which remain are in the group with the name down. And that is how I will group those points. And later when I find those group, now I will say all the points from the group up will need to go over here. All the points from the group right need to go over here. All the elements from group down need to go over here. And all the elements from the left group must go over here. So you can see here, this is the Q1 middle point, this is Q3 middle point. So this is the left group, right group, this is probably up group and down group. And as you can tell by these divisions over here regarding the tag location, we have the most of the points in this group down and in this group right. And before we jump further to this script, I just want to show you also this example for the pipes, and maybe we can try also for the cable trays. For example, we can take this view over here, and I told you we need to include this crop. And now probably this script does not point to that view, so I will close and open this script again. And now we need to change category. Pipes, we can check that value for the length, half a meter, that's okay. Run, initial tags, refine tags. Let's see the result. So we have a problem with those two tags, and I will probably move those tags to be on the right. Down there everything is okay, on the left side everything is okay. So yeah, we have like a problem with these two tags, but we can either move them down or we can just move them to the right side. And of course, if we want for some reason to have smaller number of elements, so I deleted the existing tags. I will run the script again. And yes, I think that we can see that we have now less tags than we have in the previous run. And now let's try to run the script for some cable trays. So now we just need to select category to be cable tray. And here we have small number of elements. And again, I assume that here is the problem with the tag. But anyway, in case like this, when you have small number of elements, I think you will never have a problem with the tags. So in this case, everything is okay. And now let's go in detail to see the script. So okay, in order to have the values inside the script, I will one more time run the script. And I did run for the ducts. And now let's go to Dynamo. So we have here active view, we choose here categories, and now we have all elements in the active view regarding the ducts. Now we want to know their location. We want to determine if direction of each element is parallel to x, parallel to y, and then we want to filter only those elements. So also in the previous script, when you have maybe some route which will go like this, the script was unable to deal with this kind of direction. So it is not parallel to x, it is not parallel to y, does not have a z direction, so it is some custom angle regarding the x and y plane. And now I did choose to solve this in a very easy way. I will just ignore those directions. I will filter all directions which have some custom angle between 0 and 19. My idea was probably on some plane you will have maybe 1, 2, 5, 10 times this kind of situation, and if you tag this duct over here and this duct over here, I mean you don't need even to tag this duct over here, but again, if you did tag like 80 different ducts, okay, so you will invest maybe 1 or 2 minutes after you tag all elements to also include those ducts. So that was my solution. Basically, after I filter those, we did have 80, I think 2, now we have 78. So we exclude couple of ducts. And as I told you, we have an option, and we did have this option also in the last video. Just I did create this error here. So you can choose the amount of the length which you want to exclude. So all the ducts which have a length less than half a meter will be excluded. So at the end, when we filter that, we will have 51 elements which satisfy this condition over here, and we will proceed with those elements. But before that, as I told you, we need to retrieve this crop. So you need to define the crop inside your view. Even if you don't have this crop over here, you will need to include this crop view. You don't need to include crop region visible, but I think in order to set up this crop view, you will need to turn on also this crop region visible, and then when you satisfy with the crop, you can turn it off. The script will work regardless if you have this crop region visible turned on or off. So now we did retrieve those curves. Now it is critical to know which curve, which line represent left side, right side, up and down. So now I have my own methodology how I did place the terms mathematically in order to have only one curve which represents left, right, up and down. And from this point, we also need to offset. So we have two offsets basically. So this inner curve represents our crop. This first offset will be the location for our tag elbows, and this outside curves will be the location for our tag head position. So basically from this original crop curve, we need 2 times to offset that curves. And first we will define this outer diameter offset, and then I didn't want to type 2 times something, so this middle offset will be half the dimension that you enter here. So if you enter here 2000, this middle offset will be 1000. And later we will deliver those locations. So this group over here is location for the tag head position, and this group over here, it is regarding the tag elbow position. So this is for the elbow, this is for the tag head position. Okay, now we did separate the curves. We know which curve is left, which curve is right, and so on and so on. But also now we need to group the points which we have inside this area, and also we need to assign those points to left, right, up and down groups. That we will do in this block over here. We did have similar block in the previous script. So at the end we will have a group of points which will go to the left, a group of points which will go to the right, up and down. So you can see here that the most of the points are in this down region, and also right. So we have 10 points for right, and we have 27 points for down. We have that for the points. Again, we must have exactly the same thing regarding the elements, in this case ducts. And the crucial thing which I didn't do right in the previous script, it's sorting. So now if we say this group over here it's left, this group over here it's right, and here we have up and down. So in order to avoid those collisions between the leaders of the tags, you must sort first this position of the tag end. You must also sort the position of the elbow, and you must also sort these positions of the tag head. In each case you will sort points, but at the end you must apply same rules for the elements. So you must sort points as locations, and you must also sort elements. In this case those are ducts. And what is the idea behind the sorting? So if we have some points like here, for up and down we have a logic that we need to recognize. So again, if we have x and y, now we know where each point belongs, so we will say, okay, for up and down, recognize this x component of each point and then sort by the value. So the first tag over here must be the point which have the lowest x component. So second tag will be, for example, over here. So we are sorting in this direction, and also locations will be sorted in the same direction. We will apply the same logic for this down section, but for the left and right, for example, if we have some points like here, we will take this first point, we will for all points try to sort y component of the point, and we will say the first tag will be the point with the highest value regarding the y component. The second point will be this point, and so on and so on. So the last tag must have lowest y component for that point. And that is the logic behind the sorting. And as I told you, we will sort elbow location, we will sort tag head location, but also we must sort elements to be in the same order. Then for each side we must deliver all those informations to these nodes regarding the tags. At first I did try to have only one block tag element and location, and to deliver everything to this one node, but for some reason I didn't have good results. So then I separate, for each side I did separate all those groups, and I will deliver those informations. And now here's the trick, because in the previous run we need to click once to have like initial tags, but we also needed to click twice to refine all those results. So now I did play a little bit with this transaction end and start, and also with this pass through. So now I will took all those initial created tags and I will try to refine them. And also regarding this group over here, when you take a look those tags, in the previous script all those tag end was something like here. So at each end of some element you will have end of that tag, and in some situation because of that you did have a lot of these intercepting leaders, and also it was very hard to recognize for which element we did place the tag. So I did want to change that. Now my script will, as a tag end, take the middle of the element. And in order to do that, you must at first switch this leader option from attached end to be a free end. So you can see here, when we use this attached end, we will have more intersection of the tags. The result will not be as good as when we use the free end. And also sometimes you will not be able to tell which element, for which element we did provide the tag. So again, in order to put the tag and on the middle of the element, you will need inside the script to switch from attached end to the free end, and then you can order to all tags to have new location regarding the tag end. And that is basically what this group over here will do. And you have a ability to say, okay, I want to have those leader end position to be on the middle element, or I don't want that. If it's true, you will have leader end position on the middle of the element. If it's false, you will have basically attached end and it will be in the end of the element. And in order to transfer those tags from attached end to the free end, you will need to use some Python script like this script over here. And this Python script will transfer that attached end to be a free end, and then you can assign those new locations. And pretty much that is the entire script. I think maybe it will be hard to reconstruct this script from a video, but if you understand my algorithm and if you understand my idea, I think that you will manage to recreate this script. Also, if you have any questions or suggestions, or if you have an idea how we can do this differently, you can leave a comment. And also I know that you can improve this script further, but I will not invest more time in this script because that will be like, I don't know, fifth or I don't know how many videos regarding the tags, and to be honest, it is a little bit boring. If you have a need for some custom script, if you want to improve further this script, you can contact me and order some custom script, but regarding these public videos, I think for the tags, that will be it. Thank you for watching. Bye.